All right, folks, this is going to be the first video for Note 72, and this first section is on exponential equations. So exponential equations are any kind of equations where the exponent on one or both of the numbers has some kind of a variable in it. And so what we're going to start with today are problems where you can turn, this is called a base, this is base 2, that you can turn this base and you can make this 4 also have a base 2. So what I mean by this, and I'm going to make the little note up here, if I want to rewrite 4 as 2 to some power, I can do that by saying it is 2 to the, let me get rid of that little box there, that's going to be 2 to the second power, right? 2 squared, 2 to the second power, is 4. So if I leave the first side alone, right, 2 to the x, this is going to equal, and 4, I just rewrote this as 2 to the second. So here's the thing. If these two base values, right, this 2 here is the same as this 2 here, in order for this to be equal, that means that this exponent has to be equal to that exponent. So in this case, based on what we did, x is equal to 2. Give me my highlighter back. There we go. And that's it. That one's now done. So I'm going to move over to part B now and kind of do the same thing. So I have the number 4 here, and I want to see if I can rewrite 64 as some value of 4. So let's see, if I do 4 to the second power, that's what, 16, right? 4 times 4. Yeah, clearly that's not 64. But if I take 4 to the third, 4 times 4 is 16. 16 times 4 is 64. All right. So what that means now is that I can rewrite this. So there's my 4 to the x. 64 gets replaced with 4 to the third. All right, cool. All this work. These bases now match, which means these exponents have to match. So x is in fact equal to 3. Whoops, wrong thing. I'm about to erase it. I'm like, no, I want to highlight it. All right. So that's part A and part B, right? We had an exponent on one side. We were able to make the bases work all as well. Question number 2. Now, question number 2, it's like, this is a big old step up, but the same idea holds. So I've got a base 2 here and I have a base 4. Well, I want to make them have the same base. And so I know from the very first problem we did, I'm going to kind of write this off to the side here so I have some space, right? 4 can be rewritten as 2 squared. That's a true statement, right? 4 equals 2 squared. So where I have this 4 here, I'm going to replace it with 2 squared. But I'm going to leave everything else alone. So this is going to be 2 times 5 to the x plus 9 equals. So instead of having that 4, I'm going to replace it with 2 squared. But this exponent, right, we can't lose that part either. So x minus 3. So now I've got the bases the same on the both sides. So 2 to the 5x plus 9 equals. Now on the right side over here, I have my, what's that called? Product rule. No, power rule. Power rule, that's the one I'm looking for. Sorry about that. So power rule says, what am I going to do when I have a power raised to a power? And the answer is I'm going to multiply. So that base 2 is going to stay a base 2. But now I need to take this power of 2 times x minus 3. So that's going to turn into 2x minus 6. All right, all this hard work, we've now had a base 2 here. We've got a base 2 here. Love that because now I can ignore the bases and make an equation based off of the exponents. So the equation I'm going to make here is that the exponent on the left side is equal to the exponent on the right side. And now I'm just going to solve this. And I say just solve this, but this goes back to, they're not the easiest equations, but they're also not hopefully too bad. So I'm going to go ahead and subtract 2x from both sides. All right, we're solving for x. So I'm going to get all the x's to one side. And then that's going to be a negative 6, so don't forget the sign there. I'm going to go ahead and subtract 9 from both sides. So 3x equals negative 6 minus 9 is going to be negative 15. Divide both sides by 3. And I'm getting, after all this hard work, x is equal to negative 5. Now, so far you've noticed I have not worked at all with any kind of calculator or anything, but if you did have these problems on a calculator section, you could check this, right? On your calculator, if you did 2 and then you raised it to 5 times negative 5 plus 9, your calculator can do all that math for you. That should be the same thing as 4 raised to the negative 5 minus 3, all right? So you could double check with the calculator. Obviously, right now I'm not working with one, so that is okay. All right, last but not least here for question number 3, we've got the same process. I have a base 5 and a base 25, and I need those to be the same. So the first thing I always look to do is to see if I can take the larger base 25 is the larger one, and turn it into a base 5. So can I think of something, 5 to some exponent that equal 25? And the answer is yes, it's 5 to the second, right? 5 squared. So I'm going to do some substitution here. So 5 to the 7x plus 9 equals. Now instead of that 25, I'm going to replace that with 5 squared. Exponent is x minus 4. And then I'm going to do the same thing I did in the last problem. A little power rule here, right? We have a power raised to a power. So this is going to be 5 to the 7x plus 9. That hasn't changed, and I'm okay with that not changing. And then on the right side here, I'm going to do 2 times x minus 4, so 2x, and then minus 8. So then bases now match, which means in order for this thing to be equal, this exponent has to be equal to that exponent. So at this point, I'm going to ignore the bases. The 5s are great, but I'm going to ignore them and set the 2 exponents equal to each other. All right, let's see if I can do a little bit of math here to solve this for x. Subtracting 2x from both sides. So that's going to get me, what, 5x plus 9 equals negative 8. Subtracting 9 from both sides. So 5x equals negative 17. Dividing both sides by 5, and I ran out of space. Shocking. So for this case, I'm going to have x is equal to negative 17 over 5. And no, the answers don't have to turn out to be whole numbers. That's okay. All right, this is where I'm going to go ahead and close this video for today. There will be other videos for the rest of notes. I think this is note 72. As always, let me know if you have any questions or concerns, and I'll see you in the next video.